You should be familiar with how to differentiate by now. If this wasn't here, you could differentiate this quite simply. If it was there with the power of 2 here, you would use the chain rule to differentiate it. However, this equation has 2 terms, so we need to split them up. To do that, we will use the product rule formula, which is u dv dx plus v du dx. This can also be represented as u v dash plus v u dash. V dash or u dash is the universal notation for showing how one term has been differentiated once. So if we differentiated u twice, then it would be u dash dash. Anyway, let's now assign u and v. So u would be x cubed, and then du dx would be 3x squared. Then we have v, which is everything here, 3x to the power of 4 minus 2. So dv dx is 12x cubed. We now simply plug each of these values into this formula so that we can get our answer. So it's going to be x cubed, 12x cubed plus 3x squared, 3x to the power of 4 minus 2. We can now clean up, so that's going to be 12x to the 6 plus 9x to the 6 minus 9x squared. We can then add these together because the powers are the same, leaving us with 21x6 minus 6x squared. If the question asks to factorize completely or represent in its simplest form, I would recommend factorizing this. So that would be 3x squared, 7x4 minus 2. So that is the differential of this. This problem is slightly more complicated. So before we can use the product rule, we need to make sense of all these square roots. So this can be rewritten as 1 plus x 3 over 2. This x to the minus 3 is fine, and this would be represented as 2x to the power of a third. We now have this in a way where we can see what the indexes are, and we can differentiate them easily. Let's do the same as what we did in the previous question. Using this formula, we can now find out that u is 1 plus x to the power of 3 over 2. So du dx would then be 3 over 2x to a half, and v would be x to the minus 3 minus 2x third. So dv dx would then be minus 3x to the minus 4 minus 2/3 x to the minus 2 over 3. We can now substitute all of these into here. So we're going to now get 1 plus x to the 3 over 2 minus 3x minus 4 minus 2/3 x to the minus 2 over 3 plus x to the minus 3 minus 2x thirds times 3 over 2x half. We can now expand this out, which you do by the standard quadratic factorizing, and I'm not going to run the whole string, but you should get your dy dx to be minus 3x minus 4 minus 2/3 x minus 2/3 x to the minus 5 over 2 minus 11 over 3x to the power of 5 over 6. So be really careful when expanding this. It's doing that. And then this will just be applied on both terms. You will then get a long string that you then have to clean up. And this would be your solution.